Today we're going to be comparing the volumes of cylinders and cones. Now you can already see here that I have already displayed the volume of a cylinder and the volume of a cone, both of their formulas. But what I really want us to focus on today is their relationship. How do we get these formulas and why are they important? So let's just recall by talking about the volume of a cylinder. Now a cylinder is composed of two circular bases and a lateral side where those sides connect to the circular bases. Now in order to find the volume of the cylinder, we have to multiply the base area, and that part is a circle, so the area of a circle is pi r squared. Now you almost want to imagine these circular layers just continuing to be layered until you reach the top of the cylinder, which was why you would multiply by the height. Now the volume of a cone we know is 1/3 times pi r squared times the height. Now, what do both of these formulas have in common? Well, they both have pi r squared times the height, which is the volume of a cylinder. But why does a cone have to be multiplied by 1/3? And that's what we're going to discover. So this relationship really works when the radius of the cone and the height of the cone and the cylinder are the same. So recall that a cone is made up of a circular base and a vertex. So let's just imagine that I can place this cone inside of my cylinder, because remember the volume is how many number unit cubes or the space inside of a 3D image. So I can place this cone directly inside my cylinder, and you can see that the bases match up and that the vertex is going to come right to the point. So we know that we can fit at least one cone inside of my cylinder, but let's find out how many. So I'm going to pull up my pouring and filling tool. Now this tool is great. So what I'm going to do is the exact same thing. Put this cone inside the cylinder, but to show how much it really fills, I'm going to fill it with water and then empty it into the cylinder. Right away you can see that this cylinder is about 1/3 full. So a cone only occupies 1/3 of the space of a cylinder. Now how many more cones would I need to fill into the cylinder? Well, let's find out. This would be 2. And 3. So we just observed that it takes 3 of these cones to fill one cylinder. So that tells us that a cone is 1/3 of the size of a cylinder, which was why we multiply the formula of a cylinder by 1/3. Now we can do this backwards, and I can show you how I can empty my cylinder into my cone, and it should take 3 whole tries. That's 1, 2, and 3. So it's actually quite simple, the relationship that they have. The cylinder is 3 times the size. The cone is 1/3 of the size of the cylinder. So the relationship that they have when you have the same height and the same radius is that the volume of a cone is 1/3 of the size. So you can either just multiply 1/3 times pi r squared times the height, or multiply 1/3 times the volume of the cylinder that you're comparing it to. And like we just discovered in the video, it takes 3 full cones to fill one cylinder. So let's apply what we've learned. So right now is a good time to pause the video, answer these 2 questions here with your groups, and see if you can use the relationship between the volume of a cone and the volume of a cylinder to answer these 2 questions. If for number 1 you answered that the volume of a cone is 6 centimeters cubed, then you are correct, and that's because the volume of a cone is 1/3 the size of a cylinder. So you take that 1/3, multiply it by the volume of the cylinder, which is 18 centimeters cubed, and you get 6 centimeters cubed. For number 2, the volume of the cylinder is 36 centimeters cubed. This is because the volume of the cylinder is 3 times the size of the cone. So if the cone is 12 centimeters cubed, you multiply that by 3 and you get 36 centimeters cubed. So hopefully this video helped you to better understand the relationship between the volume of cones and the volume of cylinders.